You all drop your submission. Done. Give the whole chapter to me. Okay. Shall we get started? Yeah. Right. So having said this, listen. If I ask you, what is a plus b raised to the power 1? What is it going to be? It is just a plus b. Right. If I ask you, what is a plus b raised to the power 2? So it is a square, and you have a b square here, plus 2ab in between. So it is a square plus b, a square plus 2ab plus b square. Right. So here, if you observe, the power of every variable is in such a way that the sum will come out to be 2. If you see, the power of a is 2, the power of b is 2. In the middle term, the power of a is 1 and the power of b is 1, so that when you add them, it is still coming out to be 2. The 2 refers to this index. Means to what power you actually raise the sum or difference of two numbers. Right. So if I go a step ahead and write what is a plus b, the whole raised to the power 3, what is it going to be? It will be a cube, and here you will have b cube. Right. Plus, it is 3a square b plus 3ab square plus something. Am I right? So you know how it is derived. How are you going to derive it? It is a plus b the whole square into a plus b. So if you multiply these two, you're going to get the third one. Similarly, if I go another step and ask you, what is a plus b the whole power 4? Here I'll have A cube B. Okay. 4A B cube plus B power. Okay. So how to derive this is, you're going to derive this using A plus B the whole square. So you need to square this and write it so that 1, 2, and 3, you have 3 terms. 3 terms the whole square. 1, 2, 3, 4, 5. You're going to get the 5 terms after the combination. Right. Now, if I ask you what is A plus B the whole power 5? So you can write it as A plus B the whole cube, A plus B the whole cube into A plus B the whole square. So it is going to be A power 5. And here it is going to be B power 5. Listen, plus, if you observe the pattern, right, what is happening is, you will always start with the square or whatever is the power that to which you are raising, that power to the first term. See, for example, when it is A plus B the whole square, you started with A square. A is the first term, B is the second term. So you wrote it as A square, and the last term is second term square. And the middle term is decreasing in such a way that A will decrease by power 1 and B will increase by power 1. I told you one thing at the beginning. What did I say? All the terms will be in such a way that the sum of the powers of the variables will always give you the index to the power to which you actually raised it. Here it is A cube, here it is B cube. A square B, 2 plus 1, 3. AB square, 1 plus 2, 3. Similarly, A power 4, 4A cube B, 6A square B square plus 4A B cube plus B power 4. Those who are online, are you there? Are you able to understand?
Yes, sir. Yes, sir.
So listen. So it is going to be like this. So 4, 3 plus 1, 4, 2 plus 2, 4, 1 plus 3, 4, and 4. Similarly, here it should be 5, here it should be 5. But what did I tell you? You will start with A power 5. This A should have power decreased by 1 and B should have the power increased by 1. Actually, A power 5, can I write it as A power 5 into B power 0? So B's power started with 0, it increased to 1. So what should be the next term? It should be A cube B square. And what should be the next term? A square B cube. And what should be the next term? A B power 4. And what should be the next term? B power 5. But the coefficients are not going to be the same. So it is going to be 5 here, 5. It is going to be 10 here and 10 here. But the question is, how did I know that it is going to be 10 and 10 there? That's what the question is. So, see, this falls under the branch of algebra, right? It is a pattern. You're able to see a pattern here, right? Right. If I write A plus B whole power 10 also, you'll be able to say how the pattern is going to look like. Will you be able to tell me? So if I write A plus B power 10, you will tell A power 10. So it is going to be like that. So the power of A is supposed to decrease by 1 and the power of B is supposed to increase by 1. That is first observation. Second observation is, when I have A plus B raised to the power 1, how many terms do I have? When I raise A plus B the whole power 2, I have 3. Power 3, 4, power 4, 5. It keeps on going like this. So can I say that the number of terms has something to do with the index again? So index plus 1 will give you the total number of terms that are there in the expansion. Are these 2 points getting registered? Right. If that is the case, we will be able to understand how to find those numbers. Right. We will try to understand how those numbers are. If you observe here, what are the 2 numbers which are acting as the coefficients of the variables? 1 and 1. Here, 3 variables are there. Here you have 1. Here you have 1 and the middle term is 2. So if you see, I'm not writing it as A square plus B square plus 2AB because I want that order to, I'm very particular about one thing. What is it? Order. In the sense, the power of A should always decrease by 1 in the subsequent term and the power of B should increase only by 1. Okay. In a similar way, is this an order? A cube, yes. So power has decreased by 1, 1 and 0. So power has increased by 1, 2 and 3. Okay, fine. So I will write 1 here and 1 here. I'll write 3 here and 3 here. Makes sense? In a similar way, for this, 1 here and 1 here, right? So 4, 6, 4. Again, I will write for a power 5, I'll write 1 and 1 here. What will I get? 5, 10, 10, 5. If you observe, there is something I can do with these numbers instead of me breaking my head for this. So what is happening then? If I start, yes, if I start with 1 and 1, if you start with this, right? When you increase the power by 1, you're able to observe that the number of terms are also increasing by 1. So number of terms is going to be n plus 1. But I'm able to see that there is a triangle kind of a structure being formed where the numbers also follow certain pattern. How is it? I wrote 1 and 1 here. Every such pattern for every index that I've raised, right? I wrote 1 and 1 at the ends, but in between the numbers are changing. How are they changing? That depends on what were the numbers for the previous expansion. So if I start from the beginning, here 1 and 1 is there. I wrote 1 and 1 at the end. I got this 2 because I added these 2. So here also I wrote 1 and 1. So here I got 3 and here I got 3 by adding these 2. This 1 plus 2, right? 1 plus 2 is 3. 2 plus 1 is 3. In a similar way, 1 and 1 is written here. 1 plus 3 is this 4. 3 plus 3 is this 6. And 3 plus 1 is this 4. Make sense? This is the whole chapter. Okay. So this is a pattern that is being observed. Now what we need to do is, since in the previous chapter to this, if you see permutations and combinations, we have learned something called as combinations, right? So here, one important observation that I'm able to see is the first number and the last number are same. Similarly, the second and the last but one are same, the middle number is changing. That is when I have odd number of terms. When I have even number of terms, what is happening? The first term and the last term are same. Second term and the last but one are same, and the middle 2 terms are same. Right? Meaning, I need to find out a pattern, because see, if I ask you the number of terms, you will be able to say by looking at the power. What will you say? Number of terms is just n plus 1. So that power has something to give you an answer. In a similar way, these numbers also should have some relation to the power so that we are able to derive some important conclusion, observation out of it. Okay, that is where we need to just recollect the concept of combination once. So when I talk about combination, how do you write it? There is something called as NCR. This NCR is written as n factorial by n minus r factorial into r factorial. I hope everyone remembers this. If this r factorial is not there, it will become permutation. Right? Now this is combination. Right? So when I talk about this combination, that is NCR, what is it? It is n factorial divided by n minus r factorial into r factorial. But there is a very important relation that exists between NCR and something else. That is, there is a property like this. NCR is the same as NC n minus r. Meaning, phi C2 is the same as phi C3. And this is the reason why the terms are coming out to be the same at the ends and in between also. So that depends on, so this is the property which is deciding what the coefficient of those terms are supposed to be. So to put it simple, right, you need not memorize anything. It's a pattern. Right? So is it clear? Am I clear till this point? Right? So first just make a note of whatever I gave there. Like this. So since you understood, just take down the idea, don't look at the board, write it on your own. Those are online. Could you understand?
Yes, sir.
Okay.
Yes, sir.
Are you done? Right. So here, one thing I was supposed to tell you is you're able to see this pattern, right? So this pattern is going to look something like this. Clear? So it is 1, 1, 1. Right. When it is a plus b to the whole power 0, it is 1. Right. When it is a plus b to the power of 1, it is going to be 1 times a plus 1 times b. So a plus b the whole square, 1 times a square, 1 times b square, 2 times ab. So here tell me, a cube, here it is b cube, here it is a square b, ab square. Now you know the pattern. Here 1, a power 4, b power 4, a cube b, okay, ab cube, right? So if you observe, these numbers are forming a part of a triangle, right? So this is what we call it as Pascal's triangle. Okay. Now, all that we are going to do is understanding how to decode these numbers are in terms of combination. That's it. Once you understand this, we are ready to get started with the problems. Am I clear with it? right? No. Right. Now, if you see, I told you this 5C2 is equal to 5C3, right? Now the question is, what is NC0? Anything C0 can be written as n factorial divided by n minus 0 factorial is n factorial into 0 factorial. So n factorial by n factorial is going to be 1 and 0 factorial is 1. So it is going to be 1, accepted. Now the question is, what is NCN? So it is going to be n factorial divided by n minus n factorial into n factorial. So again, you are going to get the same thing. Only thing is 0 and n in the denominator got swapped. So the answer is going to be 1. So that is why if you look at NC0, that is the coefficient of the first term. Because when we wrote the triangle, what were the extreme values? The extreme values were 1 and a 1. That 1 and 1 can be rewritten in terms of NC0 and NCN in this form, where the n is going to be the value to which you raise the expression to. That is the power of that expression. A plus b to the power n you're writing, no, that n is what is this. Okay. Now tell me what is going to be the value of NC1. It will be n factorial divided by n minus 1 factorial into 1 factorial. It is n into n minus 1 factorial divided by n minus 1 factorial. This and this will get cancelled. You're going to get n. Right. Similarly, what is going to be NC n minus 1? Why did I write NC n minus 1? Because I'm using this property. NCR is equal to NCR n minus r. So NC1 is the same as NC n minus 1. So what is NC n minus 1? It is going to be n factorial divided by n minus of n minus 1 factorial, which will be 1 factorial into n minus 1 factorial, which will be n into n minus 1 factorial divided by n minus 1 factorial. Cancel this and this. Again, it is going to be n. So this clearly tells you that the second term and the last but one term will have the power of the, will have the value as the index itself. So let's validate this and see. Right. If you observe, this thing. If you observe the second term and the last but one term, they both are the power itself. Similarly, for a plus b to the power 4, second term and last but one term, they are the powers itself. Makes sense, right? In a similar way, we'll write for NC2 alone. Then we will see how we can actually frame a pattern of writing everything in terms of NCR itself. Okay. One last thing we are going to see is what is NC2. So it is going to be n factorial divided by n minus 2 factorial into 2 factorial. What is n factorial? It is going to be n into n minus 1 into n minus 2 factorial, the whole divided by n minus 2 factorial into 2 factorial. N minus 2 factorial and n minus 2 factorial get cancelled. 2 factorial is 2 itself, because it's 2 into 1. So n into n minus 1 divided by 2. I'm not writing it as n square. N into n minus 1 by 2. Okay. So this is one thing. So similarly, what am I supposed to validate on the other side? Since I checked what is NC2, it came out to be n into n minus 1 by 2. I can conclude then NC n minus 2 should also come out as this value, but let's try to validate and see. It is going to be n factorial divided by, what is n minus 2 factorial? N minus of n minus 2, it is 2 factorial into n minus 2 factorial. If I observe, I need not solve it again because it's the same thing with swapped values in the denominator. So it is going to be n into n minus 1 the whole divided by 2. So this clearly indicates that we have a pattern, meaning we can write those coefficients, right? We need not memorize it. See, Pascal's triangle is the first step of observation. But since we already know that these numbers can be related to these combinations, now we will see how to write the value of a plus b whole raised to the power of some number n, where that n is a positive number. So you observe, the first theorem that we are going to see is a plus b raised to the power n, where n is a positive integer. Right? It's very simple, right? So don't look at that. We will write it. A plus b whole raised to the power n. So what is the first step that we are going to do? A power n, and here you are going to have b power n. Am I right? Then plus something, some coefficient is going to come, something into a power n minus 1 into b power 1. Then I'll write in this order itself. Then what should come? A power n minus 2 b square plus something into a power n minus 3 b cube plus so on till b power n. You will have a plus before that. I hope it is not confusing. I hope it is clear. Right. So first term, what I should write is, since it is 1, by default, it is going to be 1 and 1 here, but I need to choose out of NC0 and NC1, NC0 and NCN, which one am I supposed to put? So you'll always start with 0. So it is going to be NC0, right? Where the power of n is there, no? Listen to this carefully. The power of a is there, right? The power of a will be in such a way, it will be n minus this number. And the power of b will be this number itself. Did you understand? So what is it? It is NC naught into a power n, right? So when I write NC naught a power n, I can write it as a power n into b power 0 itself. The question is, how did I get this n from this? Because I need to relate them. It is n minus 0, which comes out to be n. Similarly, b's power is 0. Where did that 0 come from? It is coming from here. In a similar way, I need to increase the value. So what is happening to the value of b? It is increasing by 1, right? That's what the pattern says. So what should happen to this number at the bottom? It should be increasing by 1. So what should be the next number? It should be NC1. Now see if the logic makes sense. What should be the power of a? The power of a should be the difference of n and 1. Is it not n minus 1? And the power of b should be the base itself, that is 1. So what will be the next term? NC2. What will be the next term? NC3. Then what will be this term? What will this term be? It will be NCN. This is what the expansion of a plus b, the whole power n is. Okay. So this is the pattern. I will not say this is the formula. This is the pattern that you're supposed to remember. Okay. Make a note of it. Those are online. Am I clear?
Yes, sir.
Yes, sir.
Good. Is it easy till now? Actually, they have deleted second exercise, so it's actually easy. That is where you will be asked to find sum of the second term and fourth term as well. That is not there. It's simpler. Any questions? Revision for which one? How many chapters did you work before me to give a revision? Did you work on all? Did you work all the chapters? Did you do the work? Let me conduct a small test before your school. Okay. Shall I proceed? Listen. Now, we will see some special cases. If you take the value of a to be x and b to be y, we are going to obtain a pattern. See, we know that a plus b raised to the power n is going to be NC naught a power n b power 0 plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b square plus so on. What is going to be the last term? It will be ncn and b power n, right? If I replace a with x and b with minus y, so nc naught is not going to get affected. The combination values, so nc naught into x power n plus nc1 x power n minus 1 into minus y raised to the power 1. Right, I'll not put the minus sign outside because it will be difficult for us to remember the pattern. Actually, it should be plus minus, that's the pattern. So alternative minus signs will be there. So nc2 x power n minus 2 into minus y the whole square. So like this, if you keep on writing the pattern, it will be ncn into minus y to the power n. It depends on what the value of n is. If n is even, if n is going to be even, the last term will be y power n. If n is odd, then the last term will be minus y power n. So that is why it is always safer to write it as minus y raised to the power n instead of breaking our heads. Is that clear? So this is one case. Okay. Can I proceed? In the next case, if you take a to be 1 and b to be x, that is, if you have 1 plus x, the whole raised to the power n, it is going to be nc naught, right? It is nc naught plus nc1 x power 1 plus nc2 x square plus nc3 x cube. Because what will happen? Everywhere you will have 1 raised to the power anything is going to be 1 only. Plus so on. What is going to be the last term? It will be ncn x power n. So this is going to be the case for 1 plus x raised to the power n. Okay. So you can write it along with me. You need not wait for me to complete and then copy. All right. So third case, taking a is equal to 1 and b is equal to minus x. So what is that you're going to have? You'll have 1 minus x raised to the power n. So it is going to be nc naught plus nc1 to the power minus x to the power 1 plus nc2 minus x to the power 2 plus nc3 minus x to the power 3 plus so on plus ncn minus x to the power. That's it. Minus x to the power n. Okay. Clear with this? Okay. So trust me, the concept for this chapter is over. Only thing is solving these kind of problems. That's it. So it's only 2 classes, that's it. Right? So let's get started with the examples. The first example is expand x square plus 3 by x the whole power 4. So we need to expand and write this. So what is the solution here? X square plus 3 by x the whole raised to the power 4. So what is it going to be? 4c naught x square raised to the power 4. A raised to the power 4 plus 4c1, the first term raised to the power 3 and the second term, that is 3 by x raised to the power 1. I hope you are able to understand this. Plus 4c2 x square raised to the power 2 and 3 by x raised to the power 2 plus 4c3 x square raised to the power 1 and 3 by x raised to the power 3 plus what is going to be the last term? It will be 4c4 x square raised to the power 0 and 3 by x raised to the power 4. So how many terms are we expecting? If the power is 4, there should be 5 terms. Do we have them? 1, 2, 3, 4, 5. We have 5 terms. So you need to expand and write it completely. So when they say expanded, right, you need to find all these values and then write it. You should not leave it like this. Okay. So 4c naught is 1. So it is going to be x power 8. What is 4c1? NC1 is the number itself. Plus 4. Okay. 4 into, it is x power 6. X square the whole cube is x power 6 into 3 by x. So what will we get? 3x power 5. Right. So we'll have 3x to the power 5 plus 4c2 is 6. So you can get it like this. 4c2 is going to be 4 factorial divided by 2 factorial into 2 factorial. It is going to be 4 into 3 divided by 4. Sorry, 4 into 3 into 2 factorial divided by 2. 2 will cancel this 2 and another 2 factorial will cancel this. So you'll get the answer as 6. So basically it is 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial. 1 2 factorial gets cancelled. 1 2 factorial is 2. 2 will cancel for 2 times. So it is 6. So 6 into x square the whole square is x power 4 into 3 by x the whole square is 9 by x square. So x power 4 into 9 by x square is going to be 9x square. So 6 into 9x square. Again, we know that if 4c2 is going to, if 4c1 is 4, then what is 4c3? 4. It is 4 into x square into 3 by x cube. So it will be 4 into 3 by x. Am I right? Plus what is 4c4? 1. So 1 into, this is going to be 1. So it is going to be 81 divided by x power 4. So what is the final step? It is x power 8 plus 12x power 5 plus 54x square plus 12 divided by x. Oh, 3 cube, yeah. It should be 27. So 27 into 4 is again going to be 108. So here it is 27. It is going to be 108 divided by x plus. But x square is there. No? This x square power 1 is there. So it is, this is the final answer. Okay. So keep checking the answer also. Is it matching? So 27 into 4, 108. So whenever they say expand, don't leave it as 4c naught or something. You have to expand and write it properly. So since you understood the concept, can we go a little faster? So second question is compute 98 to the power 5. So when they say 98 to the power 5, is there any way we can handle this? So you can write this as 100 minus 2, the whole raised to the power 5. Right. So how is it going to be? It will be 5c naught into 100 raised to the power 5 plus 5c1 100 raised to the power 4 into minus 2 plus 5c2 into 100 raised to the power 3 into minus 2 square plus 5c4 into 100 raised to the power 4 into minus 2 power 4. 5c3, sorry. So it should be 5c3 into 100 raised to the power 3 into minus 100 raised to the power 2 only. Okay, correction. Yes. Plus 5c3 into 100 raised to the power 2 into minus 2 raised to the power 3 plus 5c4 into 100 raised to the power 1 into minus 2 raised to the power 4. And what will be the last term? It will be 5c5 into 100 raised to the power 0 into minus 2 raised to the power 5. Okay. So what is 5c0? It is 1. So 5c0 is 1. 100 power 5 is going to be 10 power 10. It is going to be 10 power 10. Plus 5c1 is going to be 5. So 5 into minus 2 is going to be, listen. So 5 into minus 2 is going to be minus 10. So I can write it as minus 10 into 10 power 4. Am I right? Plus what is 5c2? 5c2 is going to by 10 power, 10. Okay, 10 power 8. What is 5c2? 5c2 is 10. So 10 into minus 2 the whole square is going to be 4. So 40 into 10 power 6. So it will be 4 into 10 power 7. Am I right? So it will be 4 into 10 power 7. Am I right? So 5c2 is 10. 10 into 4 is 40. 40 into 10 power 6 is 4 into 10 power 7. Right. Plus what is 5c3? 5c2 and 5c3 should be the same. It should be again 10. So 10 into 2 cube is minus 8. So minus 8 into 10 power 4. Am I right? Plus what is 5c4? 5c4 should be the same as 5c1. 5c4 is 5. So 5 into minus 2 to the power 4 is 16. So 16 into 100. That is 10 square. Then what should be the next number? Plus 5c5 is going to be 1. 1 into 100 power 0, it is 1. So minus 2 to the, so minus 32. So we need to solve everything. Collect all the positive terms, negative terms, add and solve it. So it is going to be 10 power 10. So it will be 10 power 10 minus 10 power 9 plus 4 into 10 power 7 minus 8 into 10 power 5, right, plus 80 into 10 square minus 32. So this is what you need to write. Right. So you have to solve this. 0, 0. So first add all the positive, then you have to add this final answer. No. For that, leave some space, you guys try it. Okay. So leave some space, try it. Okay. Give me your textbook. To leave some space for this. Okay, we'll go to the next one. Shall we go to the next one? What is the question? So which one is, the next question is, which one is larger? 1.01 raised to the power of how many zeros are there? So it is 10 lakhs, right? So 1.01 raised to the power 10 lakh or 10,000. Which number is greater? Right. So whenever they have given us 1.01, you can write it as 1 plus 0.1. So this 1.01, we'll write it as 1 plus 0.1 raised to the power of 1, 2, 3, 4. Correct? 0.01, yeah. So 1 plus 0.01 raised to the power of 10 lakhs. Okay, or 10 power 6. Now the question is 1 plus x, the whole power n, as long as n is a positive integer. It can be any number. How will you write it? Plus 1 C1 into 0.01 raised to the power of how many nines? Illada. 1 power 1 then varum. Okay, sorry. 1 power 1 then varapodhu. 1 power anything, it is going to be 1 only. Right? 1 power, you will have all those nines here. And here it is going to be 1. Right? Plus, what will be the next term? 1 power something 999918. Okay. So then you will have 0.01 raised to the power 2. Okay, plus so on. It keeps on going. See, our job is only to compare, right? Which one is greater? Now, if you see, this NC0 by default is 1, whatever number it is, right? So this 10 lakh C1 is going to be 10 lakhs. So it is 10 power 6 into this 0.01 raised to the power 1. Can I write it as 10 power minus 2? Can I write it as 10 power minus 2? So 10 lakh C2, actually NC2 is n into n minus 1 by 2. But I'm not interested to find it because 10 power 6 into 10 power 2 is going to give me 10 power 4. The number that is being given here is how much? 10,000, right? So how much is it going to be? It is going to be 1 plus, it's 10 power 4 is going to be 10,000, right? You're going to add 4 zeros, no? So 1 plus 0.01 raised to the power of 10 power 6 is going to be 1 plus 10,000 plus some other positive terms are going to get added. So obviously what is being indicated here? This is definitely greater than 10 power 4, which is the number given. Is that clear? That is all we need to do. Right. Just make a note of it. Okay. Done with this? Yeah. Let me know once you're done. Hmm. Now see. The fourth example is using binomial theorem, prove that 6 power n minus 5n always leaves remainder 1 when divided by 25. Okay. See, there are two ways in which you can prove this. One is called as mathematical induction, which is deleted for you. And the other is using something called as binomial theorem. So if you observe, the 6 and the number here are giving us some hint. They are subsequent numbers. So I'll be able to derive 6 with the help of 1 plus 5. So what we are supposed to do is we need to consider something. So what we are going to consider is we will consider 1 plus x raised to the power n. Right? What is 1 plus x raised to the power n? It is going to be nc0 plus nc1 x plus nc2 x square plus so on plus ncn x power n. Right? So if I, from 1 plus x, if I want 6 power n, what is the value of x I'm supposed to substitute? I need to substitute x as 5. When I substitute x as 5 in this, what are we going to get? We'll get 6 power n is equal to nc0 is 1 plus what is nc1 here? It is n. And what is that you have substituted in the place of x? You have substituted 5. So can I write this as 5n? Plus nc2 I'm not disturbing. I know that nc2 is going to be some number. Okay, nc2 into what is x square? It is 25, right? Plus nc3 into 5 cube, that is 125. Right? It keeps on going like this. Plus I'm going to have ncn into 5 raised to the power n, where that n value is greater than 2. Why I took greater than 2 is because 5 square is 25. Now, all that I need to understand is, I need to get 6 power n minus 5n. I have 6 power n on the left hand side. Where do I have 5n on the right hand side? It is the second term. If I bring the second term to the left, right? So that is, if I write 6 power n minus 5n, it is going to be 1 is left as it is. But from here, if I see, I can take out 25 common. Why I'm concerned about 25 is because they told they divided with 25. So if I take 25 outside, then I'm going to have nc2 plus 5 times nc3 plus 5 square times nc4 plus so on. It keeps going like this. Right. So this is going to be some number, right, which is the quotient. So if you recollect this theorem, when you write a by b, then you can write a is equal to, you write it as a is equal to bq plus r. So the 6 power n minus 5n, if I take it as a, if I take this to be q, 25 is going to be b, then 1 is going to be r. Now read the question carefully. So what they are saying is, when you divide the 6 power n minus 5n with 25, right, you're going to get some quotient plus the remainder being 1. You're able to understand, right? So this is how you solve these kind of problems. So mostly you can frame the question and you can understand how the question will be framed, right? If it is 6 power n minus 5n, how are the numbers? They are subsequent numbers. Suppose they frame a question like 7 power n minus 5n. Suppose they frame it 7 power n minus 5n. You need to look at the number which has a multiple of n. That is going to be x value. And what should I consider to get 7 from that 5? instead of 1 plus x in this case, you should consider 2 plus x. But there, what will change is this number and the remainder will change. They should rephrase the question according to that way. So, but did you understand what you're supposed to consider? Right? Okay, just make a note of it. Those are online, are you able to understand?
Yes, sir.
Okay, write it down. Right. Let me know once you're done. So you all have textbooks? I'll just go through in this. Are you done with this? So now it is the exercise problems. Wait, don't be in a hurry. I'm not going to solve all of them. I'll only solve specific problems. Listen to this. So this 1 minus 2x the whole power 5. Direct problem. Right, a minus b or x minus y the whole power n4. You can do it. 2 by x minus x by 2 the whole power 5. So only thing you need to be careful is with the minus sign for the second term. So as I told you, right, whenever there is a minus sign, always you don't be in a hurry to write the minus sign first. Write it as minus x by 2 to the power 1 minus x by 2 to the power 2. Write it in that way. Okay, that you can solve it. So 2x minus 3 the whole power 6. Can do it. X by 3 plus 1 by x the whole power 5. It's similar to the first problem. So x plus 1 by x the whole power 6. You can do it. Now, those were the 5 problems which had direct formula. Right. Wait, I'm not going to do this also because this involves calculation, which that is what you need to practice with. So 96 power 3, how would you write it? 100 minus 4, the whole cube. 102 power 5. 100 plus 2 the whole power 5. 101 power 100 plus 1 the whole power 4. 99 power 100 minus 1 the whole power 5. Right? That also you can solve it. So I'll start doing it from here. So this also, you know the logic. Only thing is we are going to solve it together. That's it. Okay. Shall we get started? So the 10th question is, using binomial theorem, indicate which number is greater. 1.1 raised to the power 10,000 or 1,000. Right. So what is it going to be? 1.1 raised to the power 10,000 or 1,000. So how can I write 1.1? 1 plus 0.1 raised to the power 10,000. So what is going to be the first number? It will be 10,000 C naught, right? Plus 10,000 C1, 0.1 raised to the power 1. So what is the next term going to be? It is going to be 10,000 C2 will be 0.1 raised to the power 2. Other terms I'm not concerned about because 10,000 C naught is going to be 1. 10,000 C1 is 10,000 itself into 0.1 to the power 1 is 10 power minus 1. Plus, I'm not concerned about the numbers from here. So this 10,000 into 10 power minus 1 is going to give us 1,000. This is the number with which our comparison is based on +1 plus something. So since I have 1000 already here, it is clearly indicating that 1.1 raised to the power of 10,000 is greater than 1000. Clear? Simple problem. Shall I proceed? The 11th question is, find a plus b to the power 4 minus a minus b to the power 4. Hence, evaluate √3 plus √2 to the power 4 minus √3 minus √2 to the power 4. Okay. So you will not do this separately. What we'll do is, for this problem, first we'll solve this. A plus b power 4 plus a minus b power 4 will be solved. You will get one expression that is to be used like a formula to solve this. Okay. So what is a plus b to the power 4? I'll directly write it. So a plus b to the power 4 is 4c naught a power 4 plus 4c1 a cube b plus 4c2 a square b square plus 4c3 ab cube a power 1 b cube plus 4c4 b power 4. Next one, a minus b the whole power 4 is 4c naught a power 4. So it is understood that you will have minus plus. Okay, for this problem, I'm directly taking it because there are only 5 terms. Okay, so minus 4c1 a cube b. You would have understood this minus b is derived from here, from this term, because it is minus b power 1, it is minus b. Plus 4c2, what will we have? A square into minus b the whole square, which is b square itself. That's why I put a plus. So what will be the next term? Minus 4c3 ab cube plus 4c4 b power 4. What are we supposed to do to these two? You need to subtract them. So when we need to subtract them, you need to put a minus sign. You need to change the sign of each term. Correct? So this will get cancelled. So all the positive terms will get cancelled because their sign is getting changed. So what is that you are left out with? 4c1 a cube b plus 4c1 a cube b. 4c1 is basically 4. So you have 4 times a cube b plus, what is 4c3? 4c1 and 4c3 are the same. So plus 4 times ab cube, right? So these are the, yes. So this whole thing will get multiplied with 2. So they're coming 2 times, right? So it is going to be 8 a cube b plus 8 ab cube. So to put it simple, a plus b the whole power 4 minus a minus b the whole power 4 is 8 a cube b plus 8 ab cube. What is our job? You need to take this as a formula and solve this. So in this problem, what is the value of a? A is √3. What is the value of b? √2. Take and substitute it there. And you're done. So it is going to be 8 into √3, the whole cube is going to be 3√3. So it is going to be 3√3 into b is going to be √2 plus ab cube. A is √3 into b cube is 2√2. So how much are you going to get? So it is going to be 48√6 plus 2√6. It is 50√6. No. Yeah. So, yeah, no, 1 minute. So it is 40√6. So you will have 8 into 3√6 plus 2√6, which is 5√6. So 8 into 5 is 40. So you have 40 times √6. That's going to be the answer. Clear? So for this problem, I hope you understood that from here we derive a formula, here we apply it. Okay. right? Are you all done copying? Those are online, are you done copying?
Yes, sir.
Shall I proceed? This one, do it fast. இதோட பண்ற இது பண்ணு, புரியுது ஐடியா? புரிஞ்சுது? பண்ணு. X power 5 டா. Concentrate, concentrate and write. One 198 answer check. Okay. Done. What is the answer? 198. Huh? I'm not doing it. Everybody got it, no? So this I will do. I'll do two more problems. Okay. Listen. So listen. The 13th problem is show that 9 power n plus 1 minus 8n minus 9 is divisible by 64 whenever n is a positive integer. So the hint is very simple. Okay. You look at the question, you will know what kind of a binomial expression you are supposed to frame. So logic is very simple. It is 1 plus x raised to the power of n plus 1 this time. Because I have 9 power n plus 1. But the question is, here I have 8n. So what should I substitute in the place of x? Right. So 1 plus x to the power of n plus 1 means it is n plus 1 c naught plus n plus 1 c1 plus n plus 2, right, n plus 2 c2, sorry, n plus 1 c1 x plus n plus 2 c2 x square plus n plus 3 c3 x cube plus so on plus n plus, sorry, it is n plus 1, sorry. It is n plus 1, n plus 1. It is so on till n plus 1 c n plus 1 x power n plus 2. Okay. But the whole idea is I need 9 power n plus 1 and 8n. So in the place of x, we'll substitute 8. So when you do that, you're going to have 9 power n plus 1 is equal to n plus 1 c naught is 1 plus n plus 1 c1 is going to be n plus 1 itself into what is the value of x? What is the value of x? It will be 8 plus what is n plus 1 c2? I will leave it as it is. N plus 1 c2 into x square is there. No, x square is going to be 64 and the 64 is a number with which I'm concerned about. Right. So plus what are we going to have? N plus 1 c3 into 8 cube plus so on. Plus so on. I'm keeping on going like this. So what I will do is 9 power n plus 1, I will leave it as it is. Right, is equal to, listen to this carefully, listen. 1 plus 8 into 1 is 8. So 1 plus 8 is going to give us 9. So I'll write the 9 here plus 8n plus 64. Right, the minimum term here is going to be 64 because I can write 8 cube as 64 into 8. So 64 into some number is what I'm going to get. So what will you have? You will have 9 power n plus 1 minus 8n minus 9 is equal to 64 into capital N. So what is the remainder? So when a number is giving the remainder as 0, it is absolutely divisible by it. So this number of 9 power n plus 1 minus 8n minus 9 is divisible by 64. Am I clear with this? Yeah. So did you understand how to think? That is more important. Whatever can be the kind of problem, what are the two things you are supposed to look at? The number which has the power of n or n plus 1, whatever it is. So if the power is n, you will consider 1 plus x power n. The power is n plus 1, you will consider 1 plus x power n plus 1. And the second number you are supposed to be concerned about is the one which is the coefficient of n. So in this case, the coefficient of n is 8. So that should be the value of x. Okay, most of the cases it will be subsequent numbers. If at all they give two numbers, so depending on the gap, you need to consider the binomial theorem. For example, in this question, had it been 11 power n plus 1 minus 8n minus 9, what should you consider? 11 power n plus 1 minus 8n plus 9 minus, I should have considered 3 plus x the whole power n plus 1. That is all you're supposed to do. Okay. So this one goes in. Okay. Are you done copying? I'll do one last problem. With that, we can wind up. So if you see, the chapter itself is over. There are only 5 more problems left. It's very small. 5 more miscellaneous problems that are left. Okay. So listen to this. Listen. Listen. The 14th problem is prove that sigma r is equal to 0 to n 3 power r into NCR is equal to 4 power n. Okay, here also the problem is simple. All that you need to do is look at that 4, right? So 4 and look at the number here, it is 3. So what you can do is you can obtain that 4 by considering 1 plus x the whole power n. Okay, it is only 2 steps. Observe. Can I write this as NC0 plus NC1 into x plus NC2 into x square plus NC3 into x cube plus so on plus NCn into x power n. Can I write it like this? Now see, since this is summation, right? It is summation, right? So can I say, if I want 4 power n, what is the value of x I need to substitute? If I put x is equal to 3, right? Here it is going to be 4 power n is equal to, is it not NC0 plus NC1 into 3 plus NC2 into 3 square plus NC3 into 3 cube plus so on plus NCn into 3 to the power n. Okay. So this will be, since it is summation, we will write it as sigma. Okay. I see everywhere the top power is n, the superscript is n. So it is n. See, the below number, the subscript is changing, right? So what can I start with? I will write it as r. So it is NCR into, if you look at the multiple, the coefficient of it, it is 3. So 3, where is it starting as? When it is 0 here, it is written as 3 power 0. When it is 1 here, it is written as 3 power 1. When it is 2 here, it is written as 3 square and it keeps on going. So I can write it as NCR into 3 power r. Where is the value of r varying from? R is starting with 0 and ending with n. And this is what is 4 power n. And we are asked to prove that. Clear with this, right? So 4 power n is equal to sigma r is equal to 0 to n, NCR into 3 power r. So they just wrote it in the reverse. Okay. that's it for today. Listen, see, tomorrow I'm not there, we will work, but we will be arranging in online class. Some of them ask you for revision. What that is, six chapters are there, six chapters can't be done on Monday. Huh? Trigonometry. Yeah, covered maximum. Okay, combinations. The keywords கொடுத்தேன். I gave you the keywords, no? அப்படி மாறாது. There is a standard pattern. அது எந்த லெவல் போனாலும் it will be standard. I don't know. Maybe there is. I have to read the question or else I cannot say. You just bring the paper. பார்க்கறேன். அப்படி மாறாது. அது நான் ஸ்டாண்டர்டைஸ் பண்ணி தான் கொடுத்தேன். Maybe ஒரு டேப்லெட் காலமே போட்டுடலாம். You can do that. It will not change. So which chapter? Please tell me fast. I have to inform her. Because see, I'm not there tomorrow. Tomorrow will be an online class. Okay. So it will be from 6:15 to 7:30. But if you tell me don't waste it like previous class, don't keep him blank. If you tell me the topics, they'll help you. Which topics do you want? Because he has to prepare the PPT also. One day is not sufficient. Any topics also. Because I have already informed him to work on the miscellaneous. There will be 5 problems. No, I thought he can help you with that. Trigonometry, complex numbers, I have done most of the problems. Which one? Relations. What do you want in relations and functions? How to find domain, range, or okay. Maybe I'll ask him to solve the NCERT. We'll ask him to do it again. NCERT, and you in the meanwhile be prepared with some problems from whichever trigonometric part you want. I'll keep him informed so that he'll be prepared to solve them. Not be a shocker. He has to prepare the slides and then come. Exemplar. Level JE level problems. Are they asking from exemplar? Not needed for CBSE. அதுக்கு அந்த லெவலுக்கு சொல்லி தரணும் ஃபர்ஸ்ட். Those problems are completely different. Range domainல உங்களுக்கு அவ்வளவு இல்ல டெப்தா. Example. Other example, that's what he said. Those are all JE level problems. I don't know why they are solved. I'll inform him to solve, not an issue. I have to tell him. So can I say relations and functions part, exemplar problems is what you want. Okay. But you revise the concepts and read it so that you're not blank. Okay. So those are online. Are you all clear?
So when will we have the physics class?
Sorry, ma.
When will we have physics class? Tomorrow?
Physics will be from 4:45 to 6 and math will be from 6:15 to 7:30.
Okay, sir.
Okay, because these people have to reach home, no? That is why.
Okay, sir.
Okay, yeah. Okay, ma'am. See you.
Thank you, sir.
Yeah.